B, just checking in. So we are going to be going over a lesson today where we will also have some discussion questions for you all to answer at the end. Now, as you're going through the PowerPoint, you'll see that this has the option to do it as a group. I don't know what your situations are like in terms of connecting with your friends, but if you would like to do these discussion questions as a group, that is all good. But just because I don't know who will be doing stuff in groups and who won't be, you're still all expected to submit your answers, whether they were from a group discussion or not, individually. So even if you're working with a group of 2 to 3 other people, I still need to see all of you submit the answers to these questions, just so that I know you are all actively participating in the discussion. So having said that, we'll move forward. So like it says, this is fluids, lesson 19. So we skipped over a lesson because that was your hydraulic and pneumatic system presentation. So as long as I got those PowerPoints, you are all good. So that's why we are on 19 and not 18 or anything like that. So this is just to review. Again, we've talked about particle theory a lot in a bunch of different classes. This is just, once again, a review of it. So to review, it's all matter is made up of particles. All particles in a pure substance are identical. All particles have space between them. All particles are always moving, and adding energy will increase the movement of those particles. And then finally, all particles are attracted to one another. Now, this was back from grade 7. We've even talked a little bit about it in this unit earlier on when we're talking about mixtures and substances and all that kind of stuff. So it will be somewhat familiar. Again, it'll come up with these discussion questions later. When we're talking about volume, we've recently done experiments involving the compressibility of gases and liquids. And what were some of the things that we learned from those videos that we watched in terms of compressing solids, liquid, and gases? So normally this is where we would discuss in class. But what you should have noticed is that as we get into different states of matter, the compressibility of those states vary. So a solid will compress very, very little in terms of like ice or chalk or sugar, anything like that. You can compress it very little. And that's because, going back to the particle theory, those particles are already pretty tightly packed. So we have very little movement to push those particles anywhere closer together. Whereas with a gas, those particles are normally very spread out. So we have a lot of room to squeeze those particles together. So that's why with those videos that we've been watching, or those experiments that you've been conducting at home, like with the water bottle, you could compress the empty water bottle filled with air quite a bit, whereas as we started adding liquids or we added a solid, we were able to compress it less. And that's because those particles are already either close together in terms of a solid and even a liquid, or very spread out like a gas. So the more those particles are spread out to begin with, the more we can compress them. If they're already pretty tightly packed, we're not going to be able to compress them as much. And that's some of the things we would have seen from those different experiments had we done them in class, or if you had done them at home. When we talk about pressure, we've also done experiments when we're adding different pressures to different liquids and gases. And so once again, is that when we increase the pressure that we're putting, we're able to compress them a little bit more. So the more pressure you have, the more compressed you can make a material, whether that's a liquid or a gas. Again, solid you need a lot of pressure to compress it, whereas gases and liquids you need a little bit less pressure in order to compress them or shrink them down. When we talk about temperature, we know that temperature has an effect on those particles. So obviously when we have a difference in temperature and the effect it has on liquids and gases, we know that when we add temperature or we add energy, those particles start moving faster, which actually increases the pressure being put on the container. You'll see a lot of times that your little aerosol sprays, like your hair sprays, those are compressed gases, and they often say to not leave them by an open flame, and that's because when you add heat to those, the particles inside start to move around a lot faster, which can cause the outside to break and then explode because you're adding pressure inside the can because those particles are moving around faster looking for space to escape, which increases the pressure that's being put on the container itself. The same applies for a liquid. That's why you've seen sometimes pop cans and stuff explode when they're left out in the sun for too long. So talking about pressure, volume, and temperature, what we've just kind of gone over. Using these three ideas and these three concepts, we're going to apply them to new situations. So this is where you guys will be discussing or figuring out on your own or with a small group, and then answering the questions on the next few slides. So like it says here, as a group, you must hand in one answer sheet to the following questions. In this case, I'm going to need an answer sheet from everybody. Just again, we're not in class, so I don't know who's working together. And even if you tell me, I still want to know that everyone equally participated and has the same understanding. So be sure as part of your answer, you include theories or concepts we have discussed that help you answer these questions. So the particle theory, which we just reviewed, Pascal's law, which was back on Monday, and then anything else you think is relevant. As in-depth as you want to make your explanation is always better, right? So here are your first two discussion questions, and then I'll get on to the next ones afterwards. So if a gas is placed in a closed container, so you put it into like a Ziploc bag or like a water bottle, like that sort of thing, like a closed container where the gas cannot escape, and the size of the container is reduced. So a lot like that experiment where we had the empty water bottle and we wanted to see how much we could squish it down. What would happen to the pressure and why? So if you trapped a gas inside a closed container and shrunk the size of that container, what would happen to the pressure? So would the pressure the gas is exerting increase or decrease or stay the same? And why do you think it would do that? So again, there is a more right answer, but as long as you're able to justify why you think that, that's what I am looking for. So in question 1, what would the difference be if the fluid was liquid? And then explain. So we did question 1 based on trapping a gas and then shrinking down the size of the container. So the same question would apply, but instead it's if a liquid is placed in a closed container and the size of the container is reduced, what would happen to the pressure and why? So once again, would the pressure of the liquid increase? Would it decrease? Would it stay the same? And then why do you think that? Again, you're probably going to have a similar answer, but what would the difference be? Would the pressure increase by as much? Would it reduce by as much? Why would it stay the same? That sort of is what we're looking for in those answers. And then finally, you've got if a gas is placed in a closed container and the temperature increases. So we trap a gas and then we put that into a fireplace, into a heater. What would happen to the pressure and why? Once again, in question 4, you're repeating the same answer, but for a liquid. So if a gas is placed in a closed container and the temperature increases, what happens to the pressure? Does it increase, decrease, stay the same, and why? And then you're also going to apply that same concept to a liquid. So if you put a liquid in a closed container, increase the temperature, what would happen to the pressure and why? Would it stay the same, increase or decrease, and then why do you think that? Don't worry about these times. This is as if we were doing it in class. Obviously, you're not doing it in class, so you have the whole weekend to kind of go over these. And so, that is a summary. So what it'll do is you have the answers at the end of this PowerPoint for you. Basically, what we'll go over is you want to sort of apply the theories. So this will just talk about what you would expect to happen, but you have to explain using particle theory and Pascal's law why that would occur. So it says an increase in temperature will cause an increase in pressure and a decrease in volume. So the shrinking of a container will also lead to an increase in pressure. And the opposite of both is true. So if we decreased the temperature, it would cause a decrease in pressure, and then a increase in volume would lead to a decrease in pressure. That's all it's saying by saying that the opposite of both is true. So again, ignore this last part because our assessment is obviously going to look a little bit different, but these are the answers to help you with the previous questions, but you have to apply the science. So using particle theory or Pascal's law or whatever theory you find relevant to answer those questions. And again, I'll look for those discussion questions to be submitted to me by Monday. I hope you guys have a good weekend, and I will see you back on Monday.